We can combine functions through the operations of addition, subtraction, multiplication, and division, in addition to an operation called composition. In my example, I have the functions f of x and g of x. I can show addition of functions with the notation of f plus g of x, which means add the functions f and g together. Or I can show this as f of x plus g of x. So either notation is fine. If I substitute for f of x and g of x, get rid of the parentheses, and add like terms, I have x squared plus x minus 1. Subtraction looks very similar. The notation f minus g of x, which means the same thing as f of x minus g of x. If I make my substitution x plus 2 minus g of x, which is x squared minus 3, I can get rid of my parentheses, distributing the negative sign, and then add like terms. Negative x squared plus x plus 5. Multiplication would look like this. F times g of x, which could also be written as f of x times g of x. If I make my substitution, I have x plus 2 for f of x and x squared minus 3 for g of x. I can FOIL this out, multiply together. X times x squared is x cubed. X times negative 3 is negative 3x. 2 times x squared is 2x squared. And 2 times negative 3 is negative 6. And if I wanted to, I could rearrange the terms in decreasing order. X cubed plus 2x squared minus 3x minus 6. Division looks like this. The function f divided by the function g of x, or f of x over g of x. If I make my substitution, x plus 2 over x squared minus 3, I can't factor and simplify, so I'm done at this point. The other operation is called composition, and it looks like this. This notation stands for f of g of x. It also could be written in this form, f of g of x. The open circle stands for the composition of functions. The top notation probably makes more sense because it shows that the g function fits completely inside of the f function, or we substitute the g function into the f function. For example, using the same functions I started with before, I have f of g of x. If I make the substitution for g of x, which was x squared minus 3, I have f of x squared minus 3. That says to take the f function, which is x plus 2, and replace the x with what's inside the brackets. So the f function was x plus 2. I'm replacing x squared minus 3 where the x was in the f function. If I get rid of parentheses and simplify, I get x squared minus 1. Let's look at another example. Let's take g of f of x. Again, this would look like g of f with the other notation. And with that notation, it means to put the second function inside the first function, so f goes inside the g. G of f of x is x plus 2. My f function was x squared minus 3. I'm going to put the x plus 2 in where the x was in the g function. So the g function was x squared minus 3. Now I have the x plus 2 quantity squared minus 3. If I multiply this out, x plus 2 times x plus 2 would be x squared plus 4x plus 4 minus 3. Combining like terms, I have x squared plus 4x plus 1. Let me give you a few practice problems. Here are my functions. And I want you to find g of x minus f of x. Pause the video, do that operation, and then come back to the video to check your answer. If we make the substitution for g of x minus, and then make the substitution for f of x, we can get rid of our parentheses, distributing the negative sign throughout the second set of parentheses, minus x plus 4, and then combine like terms. Let's try another example. G of f of x, the composition of functions. Pause the video, do this operation, and then come back to the video to check your answer. G of f of x says to put the f function, x minus 4, inside the g function. So I made the substitution from f of x to x minus 4. Then we take the g function and replace every x with x minus 4. The g function said x squared plus 2 times x plus 5. So where x was, I'll replace that with x minus 4 in both cases. And now I can multiply out and simplify. Multiplying x minus 4 times x minus 4 is x squared minus 8x plus 16. Distributing the 2, 2x minus 8 plus the 5. Adding like terms, we have x squared minus 6x plus 13. So with functions, we can combine them through 5 operations: addition, subtraction, multiplication, division, and composition. Probably the one that's a little more difficult is composition, but just remember you're putting one function completely inside of the other function.